and after that we'll start. Okay, not sure. Okay, fine. So just quick update. So one of my team member was part of this KubeCon NA. So uh, yeah, that's the update which we kind of published. So if you want to take a look, what happened in the KubeCon NA, some of the updates which I find interesting, like one of it, like CNCF or cloud native communities kind of trying to embrace more of AI MLs. So of course, I mean, mostly we are learning AI ML workload on top of Kubernetes, but there are some more stuff on top of CNCF ecosystem what we can do. So that something was the highlight of even the keynote there. So that is there. I'll maybe share my screen, and that would be actually helpful. Yeah, so that's the highlight, and then um, as kind of the shift is kind of happening towards platform engineering. So I think maybe we'll pick up some of that topic in future sessions as well. And then about the some of the information about some of the discussion from Tim about the IPv6 node shutdowns and so on. And then other thing I have found interesting is the security is getting a lot of traction, which was expected, of course, that is there. And then CNCF launched a few more courses and certification exams. So I think we'll see more GitLab book things from Walid as we continue. And then there was EBBF documentary, which I would highly recommend you to watch it. EPBF is a tool or is a feature of Linux kernel. It's not a feature of Linux kernel, but it kind of makes sure that your kernel get the features or the kind of say some kind of embeddings, right, or some kind of tracing or those signatures on the fly. So, though I have talked about it earlier, but I think going over this particular documentary would give you more updates, and I'll highly recommend that everybody should watch this particular um, documentary. Yeah, that's it. I think updates which I can share about that. If anybody else want to jump in for other stuff, we'd be happy to have that. If not, then we'll kind of get into our the topic which we left off last time, and then so we kind of into the secret management chapter, is chapter number 7 of this book, and then we finished the static key encryption last time. So we kind of want to kind of start with this envelope encryption. So far, the summary of it is we have Kubernetes secrets, which we typically use for storing all the information with respect to what we call say the confidential information like passwords, keys, and so on. And for that particular, we have the secret API, and we also saw that by default, this data what we have is get put up into the HCD is in a non-encrypted mode. We just typically do base 64 encoding and put it inside the HCD, which is not good. So there are a few different ways by which we can encrypt. So we talked about one of the ways last time. Apart from that, let me quickly go over and see if there is anything. Yeah, so we can use those secrets once we have built them or once we have made them, we can use them as environment variables and as volumes. So it is recommended that we use them as a volume, because if we use them as an environment variable, first thing is um, that as you put them as environment variables, if you update the secrets, it would not be available inside the container, right? Because environment variable gets set at the beginning, and that is not good. That's one part. And second thing is, of course, if you are setting an environment variable, as people exec into the pods or containers, they can run the env command and get it. But if we use them as a volume, it does not mean that people who can exit cannot see it. It's just that it is much more easier way of um, consuming the secrets, as well as if you update the secrets outside, it would be available, or the whatever change you have done, it's available inside the container as well. So we should be using as a volume. That kind of what we kind of covered last time, and we also saw the demo how we can kind of run the etcdctl command to get the content of the from the etcd database itself. That is also what we have covered. Yeah. So with respect to that, let's now look at what is the envelope encryption. I'll just try to get my notes. Just give me a minute. Yeah, because I just tried to finish this chapter. Like I was not the lead of this particular chapter, so I took it a bit lightly. But hopefully, I can still can do the enough um, justice to the content what I kind of gone through today, right? And please, again, as I discussed, it's a discussion, so it's not that I'm teaching. Please feel free to come forward and discuss, right? And pick up the points. So the next thing what we are supposed to cover is envelope encryption. So the idea is that is we want to encrypt the keys also. So in the previous topic we talked about static encryption, in which we had a single key, and that single key is used for both doing the encryption and decryption. But that be kind of not suitable, because if somebody get access to that particular key, they can easily decrypt the content what is there. So and we will not go in that particular topic again. Um, so what you want to do is you want to even encrypt that particular key which we are using to encrypt our secret as well. So for that purpose, we can use envelope encryption. So, and we do it with the help of some kind of KMS, which is key management service, which we can have it outside of our cluster, and which can help us doing the encryption and decryption of the secrets. So what we see here is we have our secret, whatever is there. Now for every secret, we are going to generate something called as data encryption key, through which we are going to do the encryption of our data. And then with the help of KMS, we are going to have this KEC, or key encryption keys, right? And this particular key is going to encrypt the data what we have got from the previous step. So our secret got encrypted by DEK, which is data encryption key. This again we use the KEK, or key encryption keys, to encrypt it, and then we can then store together. So now you can see here, when we are putting our data inside the HCD, we are putting it along with our secret and with the data encryption key as well. But it is encrypted on top of, or with the help of the KEK what we have here. So it's an another level. So once it goes into the HCD, it is going to have the encryption key along with the content as well, the actual secret what we have. So that is how it is being persist in our HCD, which means if somebody get hold of the HCD somehow, right, they can only get the data which is encrypted, and it can be decrypted only if we have the access to the key encryption key. That is at a high level. How does it work? Um, any points here or any comments here?
This will be taken care by the Kubernetes or
Um, yeah, of course. Once we kind of set up what happens in configure that, right? We are going to configure this this particular configuration file we are going to have. In that, we are going to put down the pointers to our KMS plugin, whichever you are using. And of course, once it is being done, it would be all taken care seamlessly by Kubernetes.
okay, fine, thank you.
But of course, you have to configure your plugin with the API server what you have. Yeah. Okay. Fine. But of course, they mentioned the point at this point of time that when this book was written, right? So it was not something which is very mature, but this book is around, I think, 3 years old. But now I think it is available very much mature, at least in AWS. A KMS plugin is there, which I am aware. Walid, any comments on that if you have about that plugin of KMS?
Not really. I haven't used it yet.
Okay,
So,
no worries.
yeah.
Yeah.
But
Okay,
as you said, I mean, in the last 3 years, lots of things has happened.
correct. Yeah, this book kind of, we just want to make sure that this we are reading this book. Assume that it's kind of old book, but it still have a lot of good concepts which we can take it and then learn forward. Yeah. Okay. With respect to that, now let's move to the external providers. Now the idea is that rather than having, let me just get my notes here. Yeah, so as you can assume, right, that people or the companies, at least which are financial companies and so on, right, they would not want to have the secrets stored within the Kubernetes cluster. They would like to have some external management of it, right? And then maybe other feature of hardware security module integration as well. So all of these things people would want to have, and for that purpose, companies typically prefer to have some kind of external providers through which you can manage your secrets. So this is a central place where you can is that. So there are two prominent projects what we have there. One is Vault, and second is CyberArk. So Vault is it is open source, but I don't know what the status. We call it like that the license what is being changed by Terraform or by HashiCorp right now, but we have Open Tofu. So I assume that you are following that discussion, right? Uh, what happened with HashiCorp licenses, right? But I think we can um, take it some other time. But at a very high level, so HashiCorp changed its licensing model, which is which kind of not taken in a good kind of a say. It was not very accepted by the community who kind of put enough efforts to make those projects very successful, and that is where the CNCF has started this Open Tofu project. So if you have seen that Open Tofu, sorry, Tofu, yeah. So this is like the open source infra as a tool, like Terraform, what they have done. So for that purpose, the CNCF came under or under Linux Foundation started Open Tofu, which is kind of an open source way of doing things with the Terraform, what used to be there earlier. So yeah, it's an interesting read. Whenever you have time, please go through that as well. Anyway, so Vault and CyberArk are two projects, and I think for the purpose of the labs for learning, you can still use the Vault projects or other projects as it is, but just be aware of those licensing change. Okay, so at a high level, what we want to do right now is we don't want to keep our secret as a part of the cluster. We want to retrieve it as the need comes from the external source. So we want to manage our secret somewhere outside and then have it kind of manage it. So I assume that you know about init containers and sidecar containers in Kubernetes. Let me know if anybody not aware of what sidecars and init containers are there. Okay, so I assume that all of you are aware. So what we want to do is we want to kind of get our secrets on the fly as our app get deployed. So what we do is what we are trying to do here is as we create our pod, as the pod comes in, we are going to enable or add some of this uh, some sidecar container, um, which is Vault Agent Injector, correct? So, so what we're trying to do here is with sidecar or this particular init containers there, right? So we want to get our secrets somehow on the fly as our app starts, and then do the monitoring of it continuously. That's something which you want to do there. To achieve that, we use the mutating webhook. So what does it mean, right? So as you know that whenever we send a request, let's say when I say I want to list my pods, all of the requests which I'm telling to list the pods or any operations, right? It goes through three stages. One is authentication, authorization, and admission control. And then we access our object. So authentication, authorization, I think you understand what it is. With the help of admission control, what we can do is we can look at the request, what has come to us, and then we can uh, either modify it or we can kind of make some changes on that. So mutation and then there is validation. Yes. So either we can validate the request, whatever. Let's say if I say list me pods, right? Whether that request is good or not, I want to validate that. So there are validating webhooks or validating webhooks are there. Then we have the mutating webhooks. What does this means that you want to change something on that. So as an admin or as a uh, yeah, as an admin, you can say I can configure my Kubernetes cluster to put some policies or put some additional logic through which we can change some settings on the fly. So that is how all of these policy engine works, which I think we'll cover some other time. But for now, what is happening is as our pod is getting created, because um, in our pods, if we kind of enable, if there's a pod configuration file is there, let's see. Uh, minute. Yeah. So as you can see that this is I believe the pod configuration file. So you can see here as we put some of these annotations in our pod creation, right? And as we do that, what happens is with the help of these mutating webhooks, we are going to inject a sidecar container and then our pods get created with that particular injection, correct? And then we also have a sidecar along with it. So once the initial part is being done, we can run a sidecar container which is continuously monitoring our changes to secrets and so on. And that is how the overall thing would work. I hope it makes sense what I just conveyed to you. Okay.
Yes, yes.
Okay, great. Fine. So that is how at a very high level that what is happening here, that we kind of enable this webhook configuration, and then what we do is let me just go over further here. One more thing. Yeah. So what happens next is if we have enabled that. Hmm, Yeah, and then what we do is we kind of create some policies with Vault that what access a given pod is going to have, right? And based on that, or container is going to have, and based on that, it is going to get the right set of secrets mounted under the given location. So, for example, again, they have not given the complete examples here, but what can happen is once we have kind of configured the vault policies and the vault correctly, what happens is, yeah, so we can decide where we would like to mount our secrets, right? And that is from where the application can pick it up. This particular book does not give, at least I could not figure out the entire example, which we can try it out. But I think we can request Abdul next time because he had prepared some demos. So I can ask him to kind of give this demo the next time and then we can move forward because I could not prepare the entire demo, which I could show you. But hopefully you got the idea that there is a external vault server what we have, which stores all of our secrets. Then we create our applications to kind of say that we want to use the vault uh, setup. And then based on that, as we create the pod, vault sidecar or the init container get injected as a part of our application, which would have access to the vault server. And the way it would have access is because of the source accounts. So source accounts, what we are going to add into our pod, with that source accounts, we are going to access the vault server. And that is how it's going to work, that we create these sidecar containers or end containers with the help of the source accounts. It can access the vault server and get the respective secrets mounted in our pod or the containers, which we can then use. That is what I got figure out. Anybody has tried Vault in production? Okay, fine. So that is how it is going to be, and of course, when we look at the demo next time, it will become much more clear there. Okay. So there is one more work, what was mentioned in this particular book, which I am not sure what the status of it. But the idea is that with the help of the CSI integration, so CSI, as you recall, I think some of you would recall that we covered this in the previous chapters. So with the help of CSI, we kind of have a common storage or storage API calls for the Kubernetes to manage it. So what can happen is we can implement the the Kubernetes or the external secret management as a part of CSI. So what does it mean is we are going to have a CSI driver, and that CSI driver is going to connect with our external secret store and get our secrets mounted inside the pod with the help of temp fs mount. So with that way, what is going to happen is we'll not require the init containers of Vault and other stuff or other external secret tooling there, right? Like the way we saw the Vault init containers and so on. So what it can happen is if I enable the CSI driver, the kubelet by itself can talk to the secret server and mount our secrets inside the pod under tempfs mount, and that way it can also work. So I don't know what the status of it, but we can quickly check out. Let's just see if we can quickly do a search on it. If anybody has any input, let me know. But otherwise, I'm just going to do a quick search. What is the CSI thing on that?
Yeah, my understanding here is so you will install a binary in each of the worker nodes. The kubelet will call the CSI driver. The CSI driver will in turn call the provider, right? Which is like, for example, if you're using a Vault binary, you will have a Vault CLI installed. If you want a KMS, you will have AWS CLI installed, something like that. And then this provider will go and fetch the secret, and CSI driver will create the temporary file system and mount it to the pod.
Correct, correct. But I just want to see what the status of it right now. I mean, is it because this time when the book was done, it's kind of saying that still work is going on, I believe so. We will
Yeah.
check whether what the status of it right now, where it is, where it stores actually.
Yes. Can provide the link.
So
Here is the status. Yeah. So
yeah, it seems to be provided are there for AWS, Azure, and other stuff as well. So it seems to be there, and then just check the Git repo. Where's the link of Git repo if there is any or any other more comments? GitHub issues. Yeah, let's just check out here. code. Yes, it seems to be pretty active actually. So I think it is kind of there. So yeah, this is another way of managing secrets within the cluster, which is very interesting because in that way, um, once the secrets are available automatically to our applications, right, without doing anything, that's nothing like it, right? Because if the developer is not doing anything and it knows that where I can find secrets and do it, it would be good. So let's just check the demo what they are showing here. Cluster is there, then they have CSIs. Okay, let's see what's the next step. Hope you can see my screen, right? Let's try to see if I can. Yeah, the demo which is there on the site itself. I'm just trying to just see how they are doing it. So they are adding the CSI driver Helm chart. What next? Okay, deploy the secret store. Yes, that's the next step. So we're doing it for Azure and GCP. That's what they have enabled right now with the CSI thing. Install the provider. Are they going next or not? Where did it go? Yeah, I don't know what the status. It did not finish right after that. Okay, I think we can get this shift later. But hope. Okay, let's just see if I can't go further than this, right?
Yeah, it's a
Yes,
GIF.
GIF, right? So we can't take it forward. Let's see
Yeah.
if I download locally, we can see something. Okay. I don't think so. It would be, yeah, something is there. Wow.
No, it's opened as
Oh,
video preview or image preview, I think.
oh man, 2000 plus.
Open that file as a video or something,
Is it possible?
I guess. Go to the downloads and.
Yeah, something is. So this is where we there, right?
But yeah, we cannot finish it if you go there.
No, I think that's the same thing. What we can do. The preview is only opened. Okay. Okay, let's see if later some other time.
Yeah.
Fine. So, yeah. So, but at least what we can see here is a very active project, and it would basically. Okay, now I think because of that, this thing is hung. No, I can't. That because of that. Okay. Okay. Fine. That's fine. No. Okay. So what at least what we could figure out it is basically active project, and then there are a lot of providers, the cloud providers have been using it. So the main benefit about it, as I told you, right, that it would be available as automatically to your applications, uh, which is good, right? So what they're using it here is okay. So of course you need to mount the given volume, but as rest of the stuff is being done by the CSI driver itself. Of course, you will need to mount the volume as expected because that's a must thing that you should tell where to mount. But all the heavy lifting of talking to the provider and so on would done by the kubelet or the plugin what you install on that. Okay. The next thing is how we can use secrets in the declarative world. Now, at a high level, what is trying to talk about is how we can use in the GitOps model. So, as you know that, right? With a GitOps model, whenever we change something in our Git repo based on that, our apps get deployed or redeployed accordingly. So think about, um, I hope you heard about Argo. So what Argo can do, Argo is a CD engine for Kubernetes, and it can do other stuff as well. So the idea is that the Argo CD, which is basically the continuous deployment tool, right? It can watch your Git repo, and in the Git repo, if you change something, it would deploy the applications on the target cluster accordingly. So again, that is one. Then there's a Flux. Then there is with Jenkins also you can do it. So the idea is that you make some change in the Git, and based on that, the deployment happens. And why we are doing it? Because if we do follow the GitOps model, we know exactly when we did what change, correct? That is the main benefit of having the GitOps model. So now if we use the GitOps model, we need to figure out a way to manage the secrets as well, correct? Because if the secrets are not available to your applications, how would you kind of perform the next steps to deploy the applications and get or access to the secrets to access the other applications and so on, like databases and so on. So what we can do here is we would need to put our secrets along with the Git repo. But is that a good idea that you are putting your secrets in the Git repo? Of course not, right? Nobody would like to put the secrets in the Git repo. But what if those secrets are encrypted? So in that case, your secrets can live along with the code repo what you have. And that is what the point was mentioned here. With the help of the sealed secret example, sealed secret, we can encrypt our secrets and put it in the Git repo. And of course, if somebody can get access to it, no problem at all, right? Because for decryption, we would require the private key, which is available only the server side. So what happens in this particular scenario is we are going to configure this sealed secret controller on our Kubernetes cluster. And then what you want to do is you want to give the public keys to the developers to encrypt the data and put it anywhere. So what is happening here is we kind of set up this sealed secret controllers on our Kubernetes cluster. Now, as a developer, I can use this kubectl command or by the API, whatever method. So kubectl is a CLI utility through which I can request the public key from my sealed secret controller. Once I have public key, the developer can take the secret and encrypt it. So the example what they have given here, this is my secret YML file. So I'm just going to have my regular secret.yml file only. But what I can do is with the help of the kubectl, I can encrypt it. So what happens is, as you can see here, with the kubectl, once I have run that command, it has taken my existing secret inside another top level object, which is a sealed secret. As it is encrypted by or I use public key of the controller to encrypt it, it can be decrypted only in the server side. So once the object is getting deployed on the Kubernetes cluster, because I would see it is a sealed secret, I can first decrypt it and give it to my applications. So actually, there's a one more better picture which I have, which I can share right now, because I did one of it hands-on lab earlier. I'll quickly show you to kind of take you to this platform, but I just want to show that particular diagram to you so that it is much more clear. Yeah. So I'll give this link also on the chat if you just want to sort of take a look. Yeah. So yeah, this is kind of what I was trying to convey here, right? First of all, we can do it in the namespace based secrets. So what is happening here is we have this controller, and this controller has the public and the private keys. So private key is always available at the controller level. Public key I can give it to anybody. So public key is given to the world, and then it can encrypt that particular secret. And then you, let's say you put on the GitOps, you put on somewhere Git repo, and then what you do is you apply that particular object, right, to the Kubernetes cluster. At that point of time, the controller would use a private key to decrypt it and, of course, make it available to applications as usual. So that is how it works, and that is what is kind of mentioned here in this diagram as well. So hope it makes sense. Do you see any challenges? What can come with this particular approach? If you have. So this is the way of the management of CDR controller, what I mentioned earlier, and this is how you're going to consume it, which I already discussed here, right? That you put a secret anywhere in the world, our cluster API server is going to find out, decrypt it, and make it available to your applications. Correct. The challenge what is there if by mistake or by any chance your the private key got affected, right? Or if somebody come to know about it, it can become a bit challenging, right? Because first of all, you can decrypt by that particular private key only, and if somebody get hang of it, then they can easily decrypt with your secrets which are available in GitHub publicly. So, for example, if you have put up your the objects whatever you built and you put on git repos the sealed secret, and if your key get compromised, then people can go to your git repo and decrypt your secrets, at least, yeah, if they have access to the git repo. So that is where you can find it challenging. The other challenging with this is that if you go in the multi-cluster mode, then also it can become a bit challenging because this particular private key is typically built for per cluster level, but if you go to multi-cluster level, it can become challenging. Correct. So these two things, what we can do, what we can see. The other thing is the seal secret does not mean that people cannot read, or with even the vault also, right? That if somebody is inside the pod, right, they can access your secrets. Just make sure that you are aware of it, right? So once your pods are running and they have access to the secrets either through vault or either through sealed secret, whatever method, because they'll be available as the environment variable or as a volume. People who can access or execute to the pod, they can see it. Correct. Just make sure that you are aware of that. It is not that if uh, it's completely encrypted inside the pod itself. No, somebody if it's there, they can access it. So that is there. Some of the best practices there. One is always audit. So auditing, I think we talked about briefly in the previous chapters. And then don't leak your secret. Like for example, don't do a echo of that in your logs. That is a very that can go very wrong. And then of course, prefer to use volumes over environment variables. So these are some of the things what was kind of in store for this particular chapter. What is it? Yeah, that's kind of there what I could cover the second half. So I would request Abdul to kind of maybe give a demo of the vault if he is prepared in the next session, and then we can take it forward. Any comments or anything else for this chapter which you want to add, or anything you want to suggest?
Yeah, I'd like to discuss between alternative between this sealed secret and Mozilla SOPs. So the
Mozilla what?
difference
Sorry, I have not used Mozilla. What is it?
alternative called SOPs. I have provided the link in the chat.
Okay.
So so what happens with sealed secrets is basically it's a one-way road actually. So you as a developer, you have some secrets, you use kube seal and encrypt the keys, and then that's it, and you
Hmm.
commit to GitHub. But with this user experience is little bit hassle. You will see this code in GitHub, and it does serve the purpose of GitHubs, but at the cost that developer cannot see this back in their IDE or something, right? Um, if they want to, let's say for some reason you added a secret, but you are not sure like whether you missed a character or something, you have to again go through this update and then uh, encrypt and again make it a Git version, which is also good. But with the SOPs, it's basically integrates with your IDE also. You
Okay.
will read an unencrypted version, and then when you edit and save the file back, it is already there. It will encrypt immediately, and then you can commit it to GitHub or whatever version control you have.
Okay. So basically, so it's an external SOP management, right? Is it true?
Yes, the keys are basically in AWS KMS or anything that you integrate with this tool.
Okay.
And you will also, I think, I have not fully implemented it, but like while exploring the secret alternatives, I came across this one.
Mhm.
So you will also you need a SOPs to read a public key and then encrypt it and also decrypt it. You should require both the permissions,
Mhm.
and then at the cluster level also once you read it.
Okay. So do you have, I mean, I'm not too sure if I got it rightly, but yeah, we can explore it.
Yeah.
Um, yeah, have you tried a demo of it, Arjun? Have you
Uh,
tried it on yourself, by
I,
yourself?
I did look at some demo in this one, and I also used it some for some POC project. But yeah,
Okay.
I have seen it. Some of the teams in my previous organization use it actually.
Okay.
Uh,
Thank you for the references. And I think I heard it very long ago, but I kind of forgot it all about. So thank you for reminding me back. And yeah, if I mean, we can, it's good to know about this tool as well. Okay. Thank you. Anything else?
So we use something called as vals, like we use hen secrets, and then we have our secrets in the vault, and then we use this vals plugin to
Hmm.
get those secrets from vault. So that's, I
Right.
think, basic.
Yeah, that's something which we have seen a lot of companies does like that only that with the vault and then the sidecar and then it continuously get it is correct. Okay, so I think any other comments or anything else?
we have one more thing called external secrets,
Yes.
similar to Vault or the CyberArk, but these are like secrets exist in KMS or AWS SSM parameter store.
Mm-hmm.
So the controller will exist in Kubernetes, and you reference those keys in your, so the secrets are pushed to the SSM, like you as a developer go and update them in a path or something,
Mm-hmm.
and then you reference them in the external secret kind, and then
Mm-hmm.
it becomes a
Correct.
Kubernetes secret.
Yeah, that is also there. But it is, yeah, but it's not been used, right? It's been archived.
It's been deprecated, but
Yeah, so I think that's why I think this steel secret has come on top of it and then other things. So, right. So, yeah, then, yeah, so I think, yeah, that's not deprecated now. So I think you should use the vault on some other way of doing things. Yeah, it is no longer. And that's why maybe I think that book also does not cover it, and I kind of recall that it's kind of
yeah.
gone. Yeah. Okay. Great. So with that, I think we kind of come to end of this chapter. So what we can do in the next time, I'll request Abdul to kind of, if possible, give a demo of the vault, and then we can start with the next chapter, right? So Rahul, who is in the call right now, right? He has taken the responsibility to kind of lead the chapter 8. And of course, the idea is that we all go read back the chapter or read a given chapter, come back and have a discussion rather than having just one way. So I would highly encourage that everybody kind of go over this chapter 8 and come prepared for the next session. And then we can have discussions and then close it quickly with a lot of discussions what we can do in between. But yeah, Rahul would lead the effort. So we have the secret one taken by Abdul, and before that, 6 chapters I have taken, and we have admission control. So we are happy to kind of have anybody else take the responsibility of chapter number 9, observability. If anybody would want to volunteer, please let us know by this time or the next session. Also, you can decide and discuss.
I can take observability. Is it Thursday? Is it every Thursday
Yeah,
now?
every Thursday, yes, correct.
Because
So
Friday
there,
was
so
difficult.
there are two versions happening right now, Walid. So one is at Thursday, which is EMEA time zone, correct? And then other is the US time zone, which is later, which is 10:30 a.m. ET, correct? So which
The-
kind of this is 8 p.m. IST Indian time. If that is 3 hours more later, so we prefer to do this one. So there are two versions right now happening.
okay. So 2 sessions.
Yes, yes. So one is to kind of kind of because we could not join that very late night thing. That's why sort of starting another parallel thread on this side. Yeah, yeah. We'll be happy to, of course, have you to do this observability chapters if you wish. Yeah.
Okay.
Okay. Thank you, everyone. And of course, we should kind of try to promote more of our this particular book reading sessions, and if possibly share in a group, that would be helpful. And yeah, that's it for today. If there is any questions, let us know. Any other suggestions, pointers? Okay, so hopefully it is good session. Hope you it was worth your time. And then we'll meet you next week. Yeah.
Okay.